Hi, it's me, Geek, and I'm Dan. Welcome back to the workshop. It is time for a robot update. I've been really lax on doing any kind of YouTube updates for this. I do a lot more little stuff on Instagram and TikTok, but I've got a bunch of stuff to do. It's kind of in pieces again. I just reviewed the last update I did. I was talking about the counterbalance testing, and this has evolved a little bit since that video, but it does, having this large mass over here does make this easier to maneuver if I don't have that on it. So that was kind of last time. Since then, I've had everything mounted, all of the motors mounted. I've had it moving. I'll try and put a picture up here or something of some of the tests of it moving. But let's review. So right now, I have two axes not connected again. This is the elbow motor, so this drives this joint down here. This used to be mounted right here behind this setup, and I had a whole complicated mechanism in fact here. So the original theory was I wanted to keep more mass in the center if I could. So I wanted to put this motor here. Definitely don't want to put it out here where it would have to be dragged around. And so I came up with this fairly complicated coupling mechanism. This axle pin that goes through this hole. So there are a couple of bearings in here, and it has this kind of cross on each end, which I use to pin a cog in. In fact, here we go. So I had this thing, and this would pin through on like that, on something like that on both sides. The other side it would couple into the gearbox, and that, I mean, I'm going to say it worked pretty well. But these are the little 3D printed crosses that do the cross pinning. I had basically both ends shatter at one point or another. They just ripped the legs off, which I sort of expected to happen occasionally. It's not too big of a deal to reprint them. But even though that kind of works, it does mean that you have a gearbox behind here. You've got maybe a little bit of tweak in that coupling. You've got a little bit of tweak in this coupling. Then this gear was driving a gear that sat here, that runs the belt, that runs the thing. So there's a whole bunch of steps. Now, I wasn't super dissatisfied with that on its own, however. Well, let's go look at the gearbox. This was driving the main lift of the arm through 3 stages of planetary gearbox, and this is what's left of the last stage of planetary gearbox. It exploded. So this was, I think I did a video about reinforcing 3D print. So this is the reinforced, in order to take the load from this stage into the next stage. So this all shattered, and those all shattered, and well, so I was doing a test where I lifted the main arm kind of all the way up as I was trying to align things, and I heard crack, crunch, crack, crunch, crack, and like all of that gearbox just sort of shattered inside. So that led me to, well, I had already purchased this monster, oh my goodness, this motor, which is just absurdly oversized, because I have been trading torque for speed for torque, right? In order to get a motor that is this size to drive what is really quite a lot of torque, I've had to go through all these stages of gearbox. They each increase the torque and reduce the speed. So even when this is working, and it had been working for a chunk, right? But you are going relatively slowly because you're going through all these different stages of gearbox. So I had already purchased this massive motor, thinking, let me just try and balance this so it doesn't fall everywhere. I'd already purchased this thinking, you know what, maybe if I go up to a monster motor, I still don't think this has got enough grunt to just straight couple drive it, but maybe I can have just one gearbox reduction, like 1/4:1. I can retain a lot of the speed and the power, and so when the other gearbox exploded, I was like, okay, it's time to actually start putting this in place, which is what is going on right now. You might be able to hear the 3D printer behind me is printing parts for the second gearbox. And what I'm hoping is that actually, as I scale up all of the parts, right, so this is obviously a much chunkier Sun gear, like these are the Planet gearboxes, there's much more material in them, I'm printing them 100%, so I'm hoping that the extra depth and extra dimension gives them more ability to distribute that force over a wider surface area, such that they will hopefully not shatter, but I still need to figure out exactly how I'm going to mount this and couple it to the main axis. That remains to be seen. Meanwhile, because that's so much bigger, the original mounting for this is no longer any good because there's not enough room for both motors. And it's overly complicated, right? Like coupling to an axle and coupling to an axle and coupling to a blah blah, right? There's a bunch of stages. So this is coming around to here. So this is the belt teeth part, right? So this goes in here. This is gonna end up mounted on here, and what I'm probably gonna do this afternoon, but I decided to try and film this, is create a bracket that will bolt onto here, onto this surface that this whole thing can grab onto, so that this can mount securely on this side. Now, the advantage of that is that then it's just one belt under tension between this cog and the main elbow, so there's not like a whole chain of things. Hopefully that means less backlash. Hopefully. The downside is it does mean this whole thing, which is fairly weighty, is additional mass off center. It's not very far off center, but it's, you know, it's a little bit, so it does increase the amount of force potentially required to move this axis. Now I can offset it a bit more by putting more weight on this side if I need to, but that's the plan for him. Right, so let's talk about how has the robot evolved in plans since the last check-in. So the main thing is I have iterated the whole electronics setup a few times. In the original plan, I always wanted to have angular feedback on all of the sensors. So even though these are stepper motors and you can drive the stepper motors a certain number of steps and it should be consistent, etc., 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 I still had this idea that I wanted to have like a real sensor feedback on the exact position, not least because that means that every time I start the robot I can know exactly where it is, and in theory I can create pre-programmed movements that will always be the same, if that makes sense. Like, so I can always get to a particular position. So that was the idea, and I have all of these. I don't have a convenient way to show you. Probably up here, maybe. They're like AS50s, 5060 something magnetic encoder, angular encoder readers. So each joint has one of those, has a magnet, which is like north-south across its axis, and then one of these encoders mounted. And the original theory was I just ran all of the I2C lines for all of those sensors along the robot and back down to a controller that would read them all, and that looked great right up to the moment that I switched on any of the motors, at which point the EM interference completely destroyed that signal. And then I learned, of course, that I2C as a protocol is really not designed to be run over like half a meter of wire. It's like needs to be very short, because it's prone to interference, and like there are probably things I could have done with the wiring to try and mitigate that, but I was pretty clear that I was off to a bad start. And so what you now see is these little yellow blocks all over the place. And each of these yellow blocks contains an Arduino Nano that is situated next to or near where a sensor is, and next to the Arduino Nano is a CAN bus adapter. And what that all means is that I basically moved to a model where each joint's position is reported by its sensor. That sensor is read by the Arduino Nano next to it over I2C, but over very short wires. And then it reports that angle over the CAN bus back to a central ESP32 controller. So CAN bus, for those not familiar, is the thing that tends to be in cars. It is designed for high noise environments, EM noise environments. It's basically two wires, as the name suggests. You have a high wire and a low wire, and the bus maintains them like essentially, a little bit above midpoint voltage and a little bit below midpoint voltage, and it's using the difference between them to basically pulse bits. And they're connected at each end with a 120 ohm resistor, and the whole setup is designed to be much more resilient to EM spike noise. That's the theory anyway. So that's all wired in. It's a little bit finicky because you're now relying on another controller to do a bunch of protocol stuff. There's an extra step, it's a bit more complicated, there's another library involved, etc. I did beat my head against it for a while through confusion, but I got there in the end. So these all reported their angles back to a central, let's say, ESP32 controller, and then it was talking to the Arduino Mega, which was the original from the previous robot controller that was then wired into all of the stepper motor drivers to drive all the motors. Now, you will notice the stepper drivers are now lashed all over this robot. They used to be central. Again, that was part of like keeping all the weight in the central core. But in that version, I felt like, again, too complicated. The sensor data had to make all these hops like over the CAN bus, and then the ESP32 had like a serial connection with the Arduino Mega, which had to read it, and also had to control 6 axes. And the Mega, I think, like previously I was controlling 5, 6. I felt like I was maybe pushing the limits, and I was also making it more complicated. And I was also worried about the latency lag problem between reading the sensor data and using it to do something. So, where we are right now, each joint is in theory its own little, sort of its own little world. It can read its joint's angle, and it can send pulses to its joint's motor, which is via a controller, a driver that is near it. Now, this makes each part more complicated. There's obviously a lot of wires around, but like the actual kind of wires that run through the core are essentially the 24-volt line for each of the motors, the 5-volt line for each of the nanos, and just the CAN bus high-low lines that daisy chain through it all. And this means that the ESP32 can still be acting as a controller. It exposes a web interface. We can look at that in a sec. And it basically can say, it can find out, okay, where are the angles? And it can say, hey, this is where I want you to get to. But once it's said, hey, go to 90 degrees or whatever, that joint can kind of do all of the processing necessary to do that. It has its own feedback loops to say, how close am I getting, doing the steps, etc. So that has been a little bit better, and there's been a few times I've gotten tantalizingly close to this all working, right? Like it's mechanically has been fine, and I say I can kind of lift it and move it and whatever, but I've had a few issues, and some of those issues are the gearbox exploding. But I've also had software issues. I still have a weird problem that the camera joint, I've been seeing behavior where it'll report its angle, no problem, and then I'll tell it to go to an angle and it'll move to that angle, and then it will just stop reporting anything over the CAN bus. And I have no idea why at the moment, but we'll have to get back to that because there are bigger fish to fry with fixing the main axis. what else is going on? What else is wrong? Let me take you on a bit of a freehand tour of this and we'll think about it. So these are the AS 5060, whatever they are, magnetic encoders, and this is a pair, the Nano and CAN bus controller with another one in there, and then this is the camera one. This is the wrist one. If we come around, we can see this is the rotary axis one. There's another one in here, which is the main lift, and then down here we have the ESP32. This is the sort of the end of the CAN bus, receiving all the signals. So one of the interesting things, I've been chasing problems, right? So this is the main, what I'll call the forearm. So this whole section rotates when this gear is driven. So we have motor, gearbox, it runs this cog over this shaft to this cog, and then this cog. For a while I had the problem that this cog was sliding on the axle, so this would stall because basically this was only a pressure fit, and so this would rotate and then stop. So then I fixed this with a cross hole, and this piece of wire here is basically helping to pin this cog, so this can drive this more ruggedly, and what that exposed was this issue, which is that this section is a rectangle, and this is a square, and it creates these pinch points. And so what I did have was a problem where one of these wires wound up in a pinch point. I didn't notice it was in a pinch point because I was busy debugging some other axis that was moving, and I didn't realize that this wrist, the motor was moving, rotating around, and had been doing that. And actually the first time I noticed is it had yanked one of the connectors out, and so I lost all the sensor readings to the wrist and the camera. So I was like, well, that's weird. I've lost sensor readings suddenly. And then I realized there was smoke happening. So I switched everything off very quickly, and the smoke was because the 24-volt line had got pinched in there, and it had enough force to just slice through it, except because it didn't quite slice through it. It mushed together the positive and the negative and created a short circuit on the 24-volt line that then caused that whole series of wires to turn into a heating element. And so that was fun. Fortunately, I noticed the smoke and I turned it off and replaced all of that wire run. That was all trashed. But I do need to figure out a way to be better at making sure that that won't happen. And some of that is also having code that doesn't let me over-rotate. I have an interesting issue, I guess, with a couple of these axes. Like some of them, it really can physically, mechanically only move a certain angle. It's not 360 degrees. But some of them, like in theory, they could rotate forever, except for the wiring. So I want the flexibility to be able to let them rotate kind of as much as possible, but I need some kind of soft limit implode to prevent it from just keeping rotating until it tears itself to pieces, because that is not desirable functionality. What else have we had go wrong? So many things go wrong. I mean, the software is still a work in progress. It is troublesome to get things to hit their angle. I had for a while an idea that I would be able to, because I have the feedback from the sensors, I thought that I could tell it to move a certain number of steps, figure out how far it actually moved against how far it was supposed to move, and dynamically recalculate how many steps it requires. That was a terrible idea. It sometimes worked and sometimes would go crazy because, of course, there are all sorts of reasons that could stall motion at all, and then it would just calculate that it needed hundreds of thousands of steps to do anything, and so I removed that. But we're pretty close. I think I got fairly close, actually. At the point that I nearly set it on fire, I'd gotten pretty close to being able to fairly reliably control an axis to a point and have it, get to there and stop. The problem I then had is what I want to do is I want all of the angles being measured by the joints to be sort of aligned into a, let's call it a sensible space framework, right? Like I want to sort of know, okay, when it's pointing this way, that's 0 or that's 180, and I want those to be in sensible places. But of course, the angular readers, like there's no way to know when you're putting them in with magnets what they're going to record. They always record a specific value. So I need to offset all of those. So that was why I was driving the robot main axis up to perfectly vertical, because I wanted to get there, measure what the angle was being read as, and then adjust that to say, well, let's call that 180. And that's when the main gearbox exploded. So I need to do the mount for the elbow motor. I need to finish printing the parts for the gearbox for the main new mega motor, and figure out how exactly I'm going to couple it to the main axis. Let's have a look at that for a second. So like I say, here is where originally I had one motor mounted down here. So this is actually the sensor, the rotary sensor for the main axle, which would drive this gear. So it sits down here with its gearbox. The magnet references to that, and the big gear just interlocked into the bottom of here to drive this axis, and then the shaft, the axle for the other thing came through, and then this motor sat kind of here and coupled onto that axle. That obviously all needs to move and change. Let me just balance that there for a second. This is the problem with having everything connected, is that it's difficult to move it around. So with this moving to the other side, I've got a lot more freedom on here, but fundamentally I need some way to couple it that will be strong and have no backlash or very little backlash, and still somehow get a signal for the rotary to the encoder. And to be fair, I've solved that sort of problem here before, right? So this is the main rotary axis of the whole robot. So if I rotate that around, we have a motor here and another motor there that drives that axis. And because there's nothing on the center of the axis to do the encoder, I 3D printed this guy, who is driven when this rotates around. You can kind of just about see that this guy drives a very small gear in here, which drives a larger gear here. And that ratio between them is the same. So the herringbone gears have the same ratio as the tiny gears, so that disc ends up spinning a 1-to-1 ratio with the main robot, and then I can measure off that. So I can always do something like that for the main axis as well. So I'm less concerned about that than I am about exactly how I'm going to couple the things together. So these are the parts for what will be the bigger gearbox stage around this guy. I still just press regular bearings in the core of here. And then in theory, I guess this just needs to somehow fit. So I either want a straight coupling where it is, I don't know, maybe it sleeves over or into something with an interlock so that it will just drive it, or I can try and squeeze it below, but because the motor is so big, in order to get it centered, whatever gear would have to be smaller here. We'll see. Just at the moment I'm using a power supply to drive all of the electronics, and I just powered it up so you can see what the software looks like at the moment. We get each sensor reports its name and its rotational position, which should be stable, except of course the main arm has no magnet in front of it at the moment, so that's just like a free floating sensor. The others should be okay, and then we find out, how long ago the last update, whether it's active, whether it's moving, whether it thinks it is at its target or not. These all say false because when they start up, they basically wait and they don't know. And so I then have this button here, which I can click, which says set all of the targets for the angle to the current angle. So each axis has this concept of where have I been told to go, where am I actually, am I there yet? And what you can see is that, except for this floating one that's still getting weird readings, these have all gone true now because they know that the target they're supposed to be at is the same as the angle they are actually at. But you can see sometimes this value floats a little bit. And these then show a representation of all the angles and where they're supposed to be. And I can fill in new targets here and send them. So if I set an angle of 90 as the target I want for the camera, and then I hit the send angle, it moves to 90. And hopefully you can kind of see the target is 90. Right, and actually what you can see is what I was just talking about earlier, is that it moved and then it stopped, and now it's not reporting now it's not reporting anything, which is problematic. You may also spy that because I'm at the moment on these prototype setups, like eventually I would want a PCB properly connecting all these things, but I'm using all these DuPont cables and they keep jumping off, so I have hot glue over all of these wherever I could get it to try and stop the cables from jumping out every time, which of course when you have a moving robot you sort of like amplify that problem, and I end up chasing all these issues which just amount to, oh, one of the cables has jumped out of where it was supposed to be. So anyway, you get the idea. I've had it working but not reliably. Like each thing kind of can do enough to sort of show that it's working, but then I've had various setbacks from the electronics being weird, the software being problems, the mechanicals being like pretty much okay but dying under load, or under repeated use, should I say. Like each thing has been strong enough to move at least once. Like I've had the robot do a full arc a couple of times, but like the last time I tried it, it destroyed everything. So I'm like riding right at that edge of pushing things to their breaking point. And right now we're set back, so I need to finish making a bracket so I can remount the elbow motor. I need to finish making that, and I need to debug whatever is going on with the software, or possibly it's either the software or the electronics that is causing some weirdness. And this is where CAN bus can be a bit weird. Like CAN bus can work fine, but then if it has trouble transmitting, then the transmit buffers can fill up, and like there's something not quite right on the CAN bus, and it may be just the quality of my wiring, it may be the quality of the cable I'm using, it may be or it could be a lot of things. And it's weird because, as I say, you can get to the point where you initialize everything and everything is working and it's reporting all the sensors and it's fine, and then you try and do something and then it starts to cause problems. But anyway, enough rambling. This was an update. The robot is progressing slowly. I keep thinking I'm really close to completing, only to have some massive setback. Maybe next time I'll have it back in motion, maybe I won't. And at some point I really do need to return to finishing the electronic lead screw controller project. But anyway, hopefully this, if you are remotely interested in the robot, has been like something comprehensible as an update. And if you want to see more that's going on, follow me, add comments, ask questions. I will probably be more inspired to make updates if people are asking questions. But other than that, thanks for watching. See you next time.